So today we are going to discuss about swap management. So what is swap memory? Whenever the physical memory not enough to handle current processes, the system will use some space from the disk as a temporary memory. Is called swap memory. So in Windows we are calling as a virtual memory. So at the time of installation of Windows operating system, automatically it will choose virtual memory. But while install the Linux, we given one swap partition, swap memory we given. But when you are using the applications and databases, your swap memory is going to be low. So whenever the swap memory is going to be low, your application performance and database performance, system performance will decrease. So that is the reason, as a Linux administrator, always you have to check your swap memory in the server. So depending upon the requirement, you have to increase the swap memory. So how much swap memory we can assign at the time of installation, I am going to show you. But while you are going to install applications like databases and SAP, Big Data, Hadoop like that, the application vendor will give some requirements. So to install Oracle 12c database, 5 GB swap memory is minimum. Like that, you have to go through the guidelines of the application vendors. So depending upon that, you have to assign the swap memory. So how to increase the swap memory in Linux? Now we are going to see. So how much swap memory you are going to assign for your operating system? The general guidelines we have to follow from the OS vendors. After that, application vendors. So system with 4 GB of RAM or less require a minimum of 2 GB swap space. System with 4 GB to 16 GB, 4 GB physical swap memory is required. Systems with 16 GB to 64 GB, 8 GB is required. Systems with 64 GB RAM to 256 GB of RAM, 16 GB of the swap space is required. So these are the general guidelines. So when you take in the operating system, you have to follow the general guidelines of the particular vendor. So after that, depending upon the application's installation, the application vendor will give the requirements. So we have to go through the requirements. So we are not going to decide how much swap memory. The general guidelines we have to follow. So we have to follow the documentation. But how to increase the swap memory? We are going to see now. As a Linux administrator, this is also a regular task. You have to log into your servers. You have to check the memory in the server, how much free memory, how much utilized, how to increase the swap memory, we are going to see. So we can increase the swap memory in Linux by using two ways. So increase the swap memory in two ways. First one by using a file. Second one by using a partition. So in two scenarios, you can increase swap memory by using a file, by using a partition. Now see. First we can check what is the free memory in the system. Free space -m. So this is the command will display the free memory in the system. So total memory it will display. In interview point of view, they will ask the question how to see the memory in Linux, whether it is physical memory or swap memory. Command is free space -m. This is the total physical memory. Physical memory means RAM. So this is the used memory. Your RAM is utilizing this much of memory now. Now this is the free memory. This is the shared memory. Nothing, the applications are not there. So buffering by your kernel, cached by your kernel, a number of pages, it will use that memory. Now swap memory, this is the swap memory. So used, nothing is used because we are not used any applications here, any databases here. So like this you can see the free memory in the system. So you can also use the command free, but it shows in bytes. Free -m, it shows in the GBs. Now to see the swap partitions in the server, cat space /proc/swaps. So it shows the swap partitions in the server. So at the time of installation of Linux, we given one partition for swap, that it is showing here. So this is the 1 GB space, and you can also having the command. They will ask, is there any command? Swap on -s. So it shows the how much swap memory we given. So both are giving same output, but previous one is the file. This is the command. Remember both. They will ask any one of this, or they will ask both of this. Next, how to increase the swap memory by using a file. So in Linux, create the files with 0 bytes command is touch, but you can also create the files with size in Linux. The command is dd disk to disk input file equal to /2/0. So this is the system file, character special file. Read the input from this file. Output equal to /swap1. So you can give any name. PS equal to block size, 1 MB blocks I want to create, into how many, count equal to 1024. Then you can create 1 GB file here. dd if means input file equal to /2/0. By default, that is the logical device name system file. Output file equal to /swap1. So space bs equal to block size equal to 1 MB into count equal to 1024. It will create so 1 GB file. See, 1 GB file is created. Now this space I want to use as a swap memory. So you can check the space of the file ls space -sh file name swap1. See, 1.1 GB file I have. This is a normal file up to now, but I want to utilize this file as a swap memory. Then set up the swap file, mkswap space file name. So setting up swap space. Now activate swap on -a file name. Now you can check swap on -s. So activated, 1 GB is added to your system. So check the free memory, free space -m. Now previously we have 1 GB, now we have 2 GB of the swap space. So I want to permanent this swap memory, because once you reboot it, automatically it will deactivate. To permanent the swap memory, open the file va space /etc fstab va space /etc /fstab. Go to last line, escape shift G, insert a new line, escape O. So write down the file name swap1. So there is no mount point for swap, so just write down swap, that is a swap. So file system type is swap. Permissions are defaults 0 0. Now when you reboot your server, automatically it will activate. Otherwise every time we have to run the command swap on -a swap1, but now it will automatically activate. Now increase the swap memory by using the partition fdisk space disk name /2/sta. So already these are the partitions are available. Depending upon how many partitions in your system, you have to follow that. I am creating a new partition n, first cylinder number 1557. So you can check your last partition, last cylinder number, give the next one, plus size I am giving 1 GB plus 1G capital letter P. See the partitions. So partition number 6, save the file, save the partition table W. So now update the information to kernel partex space /2/sta. Run this command 2 times. So it is updated. Now this partition I want to use as a swap partition. Now set up the partition as a swap partition. So previously in disk management class, so we formatted the partitions, then we mounted the partitions. So those are disk based partitions. Now this partition I am going to use as a memory based. So we don't format that. So you have to set up as a swap partition. mk swap space //sta6. So activate it, swap on -a //sta6. Now check the partition, swap on -s. Now another 1 GB we added. Like this, in Linux, in real-time scenarios, when you are working with Linux servers, you can increase the swap memory by using a file or by using a partition. So depending upon the requirement, you have to choose either file or partition. So generally we are going to use partitions only. In critical scenarios, we are going to use file. Now I want to permanent this swap partition. So open the file va/etc/fs tab, go to last line, escape shift G, insert a new line. So partition number //sta6. So partition type is swap, file system type is swap, permissions are defaults 0, 0. So like this, you can permanent the swap partition. Now save the file. Now check the free memory. Now 3 GB of the swap space. Like that, depending upon the requirement in real-time scenarios, you have to increase the swap memory. Now, how to deactivate the swap? Swap off space partition number. If it is partition, partition number. If it is a file, give the file name. Now check swap on -s deactivated 1 GB. Like that, depending upon the requirement, if you want to activate, you can activate. Otherwise, you can deactivate the swap memory. So this is compulsory tasks in real-time scenarios, managing the swap memory. So just now we seen all the commands, how to see the free memory in the system, how to see the swap partitions, and how to increase the swap memory by using a file, how to increase the swap memory by using a partition. So everything we have to we see now. So in interview point of view, you have to remember here we discussed the commands to create a file with size. Command is dd. You have to remember to see the free memory in the system. Command is free-m or free command also you can see. And to see the swap partitions, this command we used cat space proc space swaps. To see the swap partitions, command is swap on -s. To activate the swap memory, swap on -a. To deactivate the swap memory, swap off. So these are the commands you have to remember. So then you can easily explain entry point of view how to see the swap memory, how to see the complete memory, how to see the swap partitions, how to activate the swap, how to deactivate the swap. These commands we have to remember. Next chapter, process management. This is also a daily task in real-time scenarios, managing the processes in Linux. See, this is the process management class. So what is process? See, a program can be made up of many processes. A process is a part of a program running in its own address space. Each process has a process ID. See, when you power on the system, when your system is booting, so many processes will run background. So when you are working with Linux operating system, so many processes we are going to open. So process, what is process? They will ask a question. A process is a part of a program running in its own address space. Each process has a process ID. In Linux, the first process of the system is init. Process ID is 1 up to RHL6. So in RHL7, the first process name is systemd, system daemon. Systemd, process name is systemd, process ID is 1 only. This is you have to remember if they will ask the question. RHL7, what is the first process? Systemd, process ID is 1. Up to RHL6, process is init, system process is init, process ID is 1. Now commands for process management. So PS, it displays the current console processes. pgrep, it finds process ID of a process. pkill, to kill the process with the process name. kill, to kill the process with the process ID. fg, to make the process as a foreground process. jobs, to see the background process. bg, to make the process as a background process. nice, increase the process priority. top, displays all the process with the CPU load average and memory. So these are the commands we can use for the process management. Next to status of process. Process states. 0 means running process, means the process is running on a processor. Capital S sleeping, the process is waiting for an event to complete. Capital R means runnable, the process is on the queue. Capital T means traced, means the process was stopped. Next to killing signals. So one is hang up. The controlling terminal has been disconnected. For example, you logged into your Linux server, you are working. So accidentally, suddenly you log out from the server. Maybe exit command you given, you logged out. Or maybe server side there is a problem. So your terminal has been disconnected. So in these scenarios, automatically background signal will work. Killing signals we are calling as killing signal number 1 will work. Next to signal number 2, so interrupt. Users can generate signal by pressing Control C. So if your process is whatever the task you are doing, if it is not properly going, you can press Control C. You can get your command prompt again. So Control C, signal number 2, interrupting. Next to quit the process. So you switch it into different shells. So if you want to come out from that, we are going to give the command exit. Exit means you are quitting from the previous process. Abort. So I want to stop the process. Abort the process. Signal number 6. Signal number 9. Generally we are going to use to kill the process. So in Windows you can go for right click task manager. For example, you can select the process. So task manager, I want to kill. Select this end task. So it will close. Like this in Linux, if you want to kill any process, we can use the signal number 9. Next, we have a command ps is there. Options of ps command. ps space hyphen capital A, list information of all processes. Small a, most frequently used processes, it will display. ps space hyphen E shows every process on the system. ps space hyphen I generate a full listing. ps space hyphen L generate a long listing of process. We are going to see practically all these options. ps space hyphen U see the list of a particular user process. ps-g to see the list of particular group process. These are the options of ps command. Now we are going to see practically all these commands. First, I want to see the current terminal process. Current terminal means how to check the terminal TTY. Terminal type /2/PTS0. Pseudo terminals we are calling as terminals. PS. So it displays the current terminal process. Bash is running now. So process ID is 2356 25934 PS command just now we given. So like this it will show time consumption in milliseconds, it will show. So this is the process ID. Now I want to kill bash process. Kill space hyphen 9 process ID 2356. It's killed. Again I have to open. Again bash is going to be run. This default shell is bash. Bash is running now. PS. So again some process ID will come. Like this you can see the process of current terminal. Command is PS. Now I want to see every process in the system. PS space hyphen E. So it displays every process in the system. But so many processes we have. I want to see page wise. PS space hyphen E space pipe more. You can see already we discussed. First process ID in Linux is 1. Process name is init. Here you can see terminal type there is a question mark. So question mark means these are all sleeping processes. At the time of booting your system, automatically they run and they stopped. So whatever their work is completed, they stopped. So here you can see TTY terminal type 1. XORG means graphical mode. We are working TTY2, TTY3, TTY4, TTY5, TTY6. Mingetti. So Linux operating system, you can switch the virtual terminals. Now see, Control Alt F2. See, I can get to another terminal. This is command prompt. Now Control Alt F3. So I can get another terminal. So like this, you can work with multiple switching to different terminals. Control Alt F1 graphical mode. So like this, you can switch and you can multiple terminals you can switch, you can work. So these are TTY2, TTY3 are those types. TTY1 we are working XORG. Now enter question mark. Now bash is running PTS 0. So PS is running, just now we given the command. More is running, just now we given the command. Like this, you can check the process page wise. PS space -e pipe more. So like this you can check. So if you want to check the particular process, PS space -e pipe grep. I want to know bash process are running or not. So bashes are running. So already terminal 2 I logged in just now. I switched, I logged in. Terminal 3 also I switched, I logged in. So bash shell is enabled there. Now whatever we are working in the graphical mode, there is another bash is there. Like that it shows where the bash process are running. Next to see the particular process ID pgrep bash. So I want to search the particular process. I have so many processes. I want to search the particular process ID. And also pgrep XORG. XORG means graphical mode. The process ID is 1726. Now I want to kill the process with the process name. So previously we killed the process with process ID. Kill space -9 is the command. Now I want to kill the process with the name. So command is pkill process name. Remember these points. Interview they will how to kill the process with process ID. Kill space -9 process ID. How to kill the process with process name. Pkill space process name. Graphical mode I am killing now. Enter. So now it is killed. So again we have to log in. Open the terminal now. Now to see the processes full list. PS space -f. So here user ID, username it shows, process ID, parent process ID. Every process has a parent ID. So current processor, schedule time, terminal type, time consumption, the command path. Now to see the process with the long list PS-L. So here status of process, capital sleeping, waiting for complete the event. R means running process. So process ID, parent process ID, current to processor, priority value, nice value. What is the address means shared memory it is utilizing, waiting for an event to complete, terminal type, time consumption, bash. Here important thing in entry point of view is how to increase the priority of a process. Now we are working with bash shell. The priority is now bash shell. Now I want to give the priority to sh shell. So to increase the priority of a process, command is nice space nice value. You can give up to 19. So I am give number 4 process name sh. Now see automatically the priority goes to sh. So in real times your database administrator wants to increase the priority of for a CTL process, for a control file process. So as a Linux administrator, you have to know the process name from the database administrator. Then you can apply this command nice space -4, give the process name. See, now the priority goes to SH. Now check the priority number, PS-L. So priority number is 84. So you increased the priority of the process. Again, if you want to give the priority to bash, nice, space -10 or -8, you can give the name -8, bash. Now the priority goes to bash, PS-L. Now this is the priority number, 84 already highest priority, plus 8 you given, 92. The priority number goes to bash cell. Like this, in interview point of view, they will ask the question how to increase the priority of a process. Nice command, values up to 19, 9 only you can apply, you cannot cross that limit. Next, how to make the process as a background process. Before going to that, first check the particular user process, ps-u space username or user ID. So ps space -u username. I want to check root user process. So we logged in as a root user, every process is root only. So if you want to check the user process Siva, ps -u Siva. Siva not logged in, he is not doing anything. ps space -u Charan, he is not logged in, he is not doing anything. To check the particular group process, ps-g group name, for example AWS or Java or DBA. Like that we can check the particular group process. So to make the process as a background process, use the command Firefox. For example, I am telling you real times, maybe you are going to run one backup command task. So the backup maybe take 3 hours or 2 hours or 5 hours time, but meanwhile you have to work on the server, so you can make it the process background. Like you are creating database, so for creating the database it will take 3 hours time, meanwhile you have to run some commands. So in that scenarios, after giving the task syntax, so last one, see Firefox 6, here I am showing you Firefox. So this is the web browser in Linux. So Firefox is open. So when I am working with this web browser, here I cannot work, I can't do any work here. So until I can close that. So now see, I am closing that. So now I can get the prompt, I can do the work. But I want to use Firefox, at the same time I want to work on the terminal. So make the process as a background process. Firefox space, give the ampersand symbol. See, it is running, Firefox is running. Here meanwhile I can work. Like you can make the process as background. So whatever the task you given there, syntax, space ampersand symbol if you give, it goes to background. Now I want to see the background process. Command is jobs. It displays the background process. This is the process ID, background process ID 1. It is running, it's running, Firefox is running. Now again I want to make it foreground. So to make the process as a foreground, fg space percentage job ID. Now see, this is came under foreground. I want to close this process, Control C. Automatically it will close. Then I can get the prompt. Like this, you can make the process as background and foreground. Next, to see process tree, PS tree, this is the command displays the all the processes with the tree structure, from where the process is started, how the tree structure is there, it will display. Now see, first process ID, first process name init. So network starts like this. This is the tree structure, it is divided. Like this, if you want to see the process with the tree structure, PS tree space pipe space more, page wise you can see the processes structure. Next to real times, generally 99%, 100% we are going to use this command top. So it will display, like in task manager, it will display total tasks, how many tasks are running. Total are 120, 175, but running is only one. Remaining 127, 174 are sleeping process, stopped process, zombie process. Zombie process means, so if you kill the process also, some process they will utilize the memory from your system, those processes are called zombie process. So we have to kill the parent process, then zombie process will go. Now how much CPU percentage utilizing, how much system percentage utilizing, nice values, how much percentage utilizing, so how much CPU, sorry, idle system idle time. So in interview they will ask the question how to see the system idle time. So give the command top, you can see here 97% idle. So here every process is running, whatever the process is running. So process ID, user, priority number, nice values, how much virtual memory utilizing by the process, resident set of memory means physical memory, and how much shared memory it is utilizing, paging files. So S means status of process, percentage of CPU, how much is loading, how much complete memory it is utilizing, how much time consumption it is taking, milliseconds. So what is the command it is using? So you can use this command, top command. So you have to monitor your process, and also here you can check the memory also. So how much physical memory is there, how much used, how much free. So everything we have to check by using the top command. So you can run this command on any server, then you can easily understand the system status, how much idle percentage, system CPU utilizations, memory utilizations. So this is the top command. So this is the process management. So next class we are going to discuss about package management, RPM, Red Hat Package Manager, how to install package, what is package, how the Linux packages will come, how do you identify the Linux package, how to install, upgrade, remove, manage the packages. We are going to see in our next classes. Okay.